Hello everyone, my name is Charmaine Pereiras and today I'll be presenting on Chapter 8, Avoiding the Einstein Syndrome, the Importance of Converging Evidence. The main three key points of this chapter include the principle of connectivity, the gradual synthesis model, and the principle of converging evidence. The principle of connectivity entails that when a new theory arises, it must have a link to existing empirical evidence that ties in with the theory, meaning that the new theory should be described in relation to the old theories. There are two violations of connectivity, which are unfalsifiable theories and rejection of old data. Pseudoscience tries to bypass this principle by using these methods, but scientists usually catch on and reject their theories. Third, the principle of connectivity elaborates on old evidence, and I will show you an example in the next slide. The second main point is the gradual synthesis model, and it states that advances in science comes from various experiments, not just through one scientific breakthrough. It is saying that a single experiment is not enough to make an advance in science. It is only one part of the many evidence that can be used to come to a conclusion. Also, there is no such thing as having special knowledge when it comes to gathering scientific information. Stanovich warns us that pseudoscience claims to know secret information, but Stanovich counters that science is a public domain, so it's not likely that scientists will withhold information from others. The third point is the principle of converging evidence, which is when scientists investigate the flaws in several studies and implement it to their own experiment's conclusion. It's saying that evidence that yield alike results can contribute to a stronger conclusion and that no one experiment is perfectly designed. So there are limitations that determine the strength of the conclusion. Even though there may be flaws in the experiments, they can still be analyzed and found out if they are useful or not. For example, if all of the experiments were limited in a similar way, then it would undermine the confidence in the conclusion, whereas if the experiments were limited in different ways, then it would make the conclusion stronger because they would know that there is no confounding factor that is shared in all of the experiments. Third, theory testing gathers all supporting evidence to decide whether theories should be accepted or denied. The textbook provides a chart and it listed theories in which each were labeled supported or untested by two experiments to come to the conclusion whether the theory should be refuted or accepted. The theory is highly convergent when the support is consistent with the experiments were done. It would result in keeping the highly supported ones and eliminating the rest. Lastly, it looks for different methods to obtain converging evidence. Different settings such as laboratory and non-laboratory environments such as field studies are important when conducting an experiment because it can strengthen the conclusion when it is applied to regular people and not just test subjects. Now I'll be presenting on the examples of connectivity. In the textbook, the example is about Einstein's theories, and this applies to the principle of connectivity because his theories build upon Newton's theories about motion, and they both make the same predictions using their theories. And even though Einstein's theories were more superior, it didn't reject Newton's theories. A more modern example are the COVID-19 vaccines because they correlate with the previous studies about vaccines. So they were formulated by using this idea of taking the active or inactive virus and injecting it to the body, which is used in many kinds of vaccines. However, mRNA vaccines, which are the ones used for COVID-19, elaborate on this idea and instead use messenger RNA to command the cells to produce COVID spikes, which is detected by the immune system and responds by making antibodies. Therefore, it explains the previous ideas about vaccines in terms of introducing something foreign to the body, which helps strengthen the immune system. I will now be briefly talking about the gradual synthesis model. In the textbook, the example was about the composition of genes. It took 10 years of work to come to the conclusion whether genes are made of nucleic acid or proteins. Beliefs were changed and the researchers came to a consensus by looking at all the different studies throughout the 10 years. The second example is about global warming. Researchers analyzed different studies to determine how to delay the effects of global warming. Global warming isn't just caused by one factor, and it can't be solved by just one solution. So researchers must look for empirical evidence from a wide array of experiments to figure out what can be done about it. Lastly, I'll be talking about the examples of converging evidence. The textbook example provided is about video games causing aggression. Research shows that it does influence behavior, but it is relatively small. They came to this conclusion not just by one experiment, but many experiments that show similar results, therefore having converging evidence. Video game executives try to resist the evidence because they think that the proof relies on a single critical demonstration instead of a convergence of many studies throughout the years. The second example is about cell phone use and driving, and it has been proven to be very dangerous and is one of the factors for car accidents. Stanovich warns us that cell phone and car companies try to hide this fact and disregard the science behind it just to make profit by releasing more types of technology that can be a distraction while driving. The conclusion is highly convergent because it has been done in laboratory studies, field studies, correlational studies, and true experiments. To wrap things up, I have two discussion questions for you all. First is, why do you think that connectivity and converging principle is extremely important when it comes to discovering new treatment for diseases? Think about my example about the COVID-19 vaccines. And the second question is, how can one convince another that a scientific breakthrough is not possible by just one single experiment? Think about the gradual synthesis method and why this is important. Thank you for listening to my presentation.